Bismillahirrahmanirrahim. Uh, we'll solve this problem, example 3.9, and it's a very practical problem. As you can see, normally on a highway, we are traveling from one point to another point. Um, this is an example when you're traveling at some level and you uh, have to get to the other level, that is from a tunnel to a bridge. So obviously for that, uh, when we are traveling, and this is a profile view, and you can see that we were at this tunnel that has an elevation of 100 feet, and then we have to go to this bridge that is 40 feet. In between that, we have to negotiate some grade, we have to ascend some grade, and in order to ascend this grade, we have to have two curves. The first one is the sag curve from 0 to some percent, and then there is a crest curve in which from some grade to the 0 grade. Understanding this figure is very important in the context of this problem. Let's see what is given to us. Let's see the first statement. There is an existing tunnel that to be connected a newly constructed bridge with sag and a crest vertical curve. The profile view is shown in this figure 3.8. You have to develop a vertical alignment, means you need to know the length of the curves and to connect the tunnel and the highest point, possibly design speed for the curve. We have to determine what should be this speed that should be posted or that should be available for the safe stopping side distance. And then we have to compute what is where is PVC and where is the PVI and PVT of both sag and vertical curve. If we look at this, this in detail, what I've done here is uh, I've drawn this straight line, this tangent, and this is one curve, and this is another curve. Now, as you can see that this is at the level, so the first grade of sag curve will be 0, naturally, and there is some grade. And since this is an equal tangent, we can say that the upward grade for this this sag curve will be same as the downward grade uh, or the ascending grade for the crest vertical curve. And naturally, this grade will also be 0. Another thing we can note is the distance between two curve is 1200 feet. So this is another thing. The third thing is the elevation difference between the two curve is 40 feet. How? That because the bridge deck is elevation 140 feet, the elevation of tunnel feet is 100 feet, so the distance is 100 feet. So based on these circumstances, we develop some equation as shown in the next page. Now, as such, I can say that the G1S is equal to G2C that I have drawn in the figure, and I know the grade 2 of the set vertical curve is equal to the grade 1 of the crest vertical curve. As I've said, that PVI and PVC curve is 1200. So the length of sag and the length of curve cannot be more than 1200. From also we can see that since one of the grades on both the side is 0, so the algebraic difference the sag of vertical curve and the crest vertical, the A will be same and we can categorize this is A. From the basic equation, we know that AL over 200 of sag curve plus AL of 200, the elevation of this curve, the first curve and the elevation of the second curve is 40 feet that we can see. So, we're just doing some algebra, we can find that A over 200, E multiplied by 1200 is 40. So that's A is 6.67. So once A is known to us, we know that from this equation, LS over LC is equal to 100. We also know that LS is nothing but K times A, and this is also K times A. So we can say this KS, AS plus KC, AC is equal to 1200. But since A is same, so we can say that Ks plus Kc is nothing but 1200 over A. And since Ks is equal to Kc, then we have to have some we have to apply this trial and error in which we find some value of Ks and some value of Kc, and the sum becomes 180. So what we can know that uh, for sag curve, if I look at, let me show that figure for sag curve, the for 50 miles per hour, this K is 96. For instance, we have say 50 miles per hour, this is K is 96. And for sag curve for 50 miles per hour, so it's 84. So this becomes, when I add 97, 84, I'll get the value of what? 180. And that's what we have. So what we need to do is to uh, arrive at one speed that on that speed, if we add the K values, it becomes 180. For instance, if we select, say, the speed of, say, 40, K is 64. And for 40, crest curve, K is 44. So if you add 64 and 44, it becomes 108. So actually, but this, if I add two values of K's, this become 108. But this will not solve. That's how, with some trial and error, we come up with this value, and we said that 50 miles per hour speed at the value of satisfied this equation, the situation we are having in this problem. So once we know that thing, then obviously, I'll say now 96 and 84 is confirmed. So now we know the length of the curve. And once we know the length of the curve, everything becomes trivial. PVI becomes 320 feet, PVT is 640 feet. But because we have to add the length of PVC and this PVT for the crest curve is simply 1200 feet. So that's how this problem can be solved. I hope I was able to communicate. Thank you very much for your time and